Hello, everybody. So welcome to Introduction to DSP, Digital Signal Processing. Okay, so today is the first meeting of the class, and we will open two classrooms, this one and the next one. Okay, so I explain. So my TAs, one of my TAs is going to check if she can enter the other room, and the plan is that for every lecture we will synchronize both classrooms using the equipment over here. So it has been working last year, so I'm pretty sure that we can do that again for this year. Okay, so for those of you that are standing behind, sorry for this. So for that, we are still handling that. So please just bear with me. It's okay to stand there, or if you want to sit down on the floor, it's okay to me too. 可以是不是 Okay, so yeah, you may please go to the other room. And let us know if you cannot hear me. Okay, there are an empty room in the next classroom, right? But otherwise, yeah. So any questions so far? So let's wait for a while until our fellow classmates move to the other room. So hopefully, how are you today? Yeah, 2025, right? So my name is Yiwen Liu. 我叫刘一文啊 and just a bit of an introduction of myself. I received my PhD in 2006 and from Stanford University, and my thesis is about audio watermarking. So signal processing really is my specialty. And since 15 years ago, I joined NTHU, and this is a list of all the courses I have taught. Okay, so as you can see, I have taught probability 4 times, linear algebra 5 times, and PDE and complex variable 3 times, and another PDE course with numerical method, I've taught that 2 times. And this is going to be my 5th time teaching Introduction to DSP. But other than that, I've also taught graduate level, 研究所, graduate level DSP 7 times, and my own graduate level course called Analysis and Synthesis of Digital Audio Signals. I've taught that for more than 10 times, together with neural networks, and I've even taught computer programming for 1 time. All right, so this is about my teaching career to tell you. And so now let's spend some time to talk about requirement, suggestions, and how we are going to be graded, and so on and so forth, how we are going to organize our course for this semester. So first thing is about the size of class. So we do have a size, currently the enrollment is about 150 something. Okay, so definitely not, we cannot have everybody to sit in the same room. So that's why we need to meet at 2 rooms at the same time using synchronous broadcasting. And this room is going to be the main room, okay? And the other room as the overflow room, Lectures all will be recorded. Can we confirm that? Are we going to TAs? TAs. Oh, yeah. Are we going to record every lecture? Right? Yeah. So lectures will be, I just confirmed. The lectures will all be recorded, and video will be provided after class. Okay. So that being said, what is the meaning of having 2 rooms? So the main room. In the main room, I have 1 requirement. Okay. In the main room, I require that please do not bring food into the classroom. No eating. Drinks, I'm fine. Okay. But please don't bring anything that's too delicious, because it's going to be a distraction for me and for others. Okay. If you really need to eat your lunch, I understand that we have a lot of students on campus, and typically you don't have enough time to have lunch, right? And this is the first class after lunch hour. So if you really need to eat, go to the other room. Okay. Can we agree on that? Yeah. If you really need to, you're really hungry, you really need to eat, go to the other room. Okay. So this is the main room. The other room is the overflow room, and in this semester, I plan to teach with a mixture of PowerPoint and Blackboard. I'm going to use both, right? And pre-notes, basically handout. Handout will be provided, I promise. It will be available beforehand. For this semester, I'm going to create the handout. If you know, last year we didn't do that. Last year is purely teaching from iPad. But this year I'm going to try PowerPoint and Blackboard, okay? And what are the prerequisites for this course? DSP has a lot to do with math, And you need to be comfortable with calculus and complex numbers in particular. Complex number, x plus y, iy, okay? Complex numbers. And if you are from our College of ECS, the prerequisite really is signals and systems. That's another course, a kind of a foundation for DSP. So if you have taken signals and systems, you will be fine. Okay, you can continue with this course. But in case you haven't, so how can you tell you have taken signals and systems or equivalent? So I suggest that you can ask yourself, am I familiar with Z transform? Do I know convolution? Do I know what is a delta function? Yes, delta function, right? And do I know Fourier transform in general? Okay. So if the answer is yes, you are going to be okay, right? But if the answer is no, then so I've told you that this is a prerequisite. Okay, we are going to build upon this concept when we learn DSP. Okay, is that clear? Z transform, convolution, Fourier transform, and generally complex numbers, delta function, things like these. Okay. But with that, let's talk a bit about DSP now, right? So if C stands for continuous, D stands for discrete. So the overall workflow for DSP is going to be like this graph. Okay. On the very far left, we have the input signal, which is continuous as a function of time, a continuous time variable t. Okay, continuous time t. And we explained that we recommend that the signal needs to first go through an analog filter that is called anti-aliasing filter. Okay, after that, the signal is still in continuous time, but then we convert it from continuous to discrete time using some kind of sampling period t. Okay, sampling period. We'll explain that in a moment. But then after that, things become a sequence of number, x of n. N is basically integer, 1, 2, 3, 4, 5. Okay, n is integer. And then in this discrete time domain, we will process the signal using this equation only. Okay, so it's like if you need to know enough to ignore DSP, 知道够多可以忽略. If you don't need to know enough to ignore DSP, I'm going to tell you that, share with you that the only equation you need to really master is this difference equation. 这是一个差分方式, it's a difference equation, right? So if we read the details of this equation, and we're going to encounter this a lot and a lot, right? So let me explain. So let's say if x is our input signal and y is what this equation produces, the output. Okay? So we are going to express the output as a linear combination of the input signal, linear combination, as well as the output signal itself in the past samples. Okay, looking backward in time. Okay, so this is what a difference equation is, and is going to be applied almost always for DSP. Okay, nothing more than this. So almost during the entire semester, I'm going to say at least 70% of the time, we are going to study about this equation. How do we use it to process our signal? So we have the input, we have the output, we are processing a signal. So far, so good. Input, output, processing. We're going to process the signal in the discrete time domain. And then after that, our signal has to come back to the real world. So it needs to be converted from discrete time back to continuous time, D to C conversion, with the same sampling period. And so that the output that we can transmit, or you can listen to, we can watch, we can, so the output for the entire system will go back to the continuous time domain with the variable t as a function of t. Okay, so that's sort of the overall flow chart for DSP, digital signal processing. And along the way, you will learn the concept of going to frequency domain. Okay, we're going to do a lot of frequency domain discussion. So we will introduce, we'll review the continuous time Fourier transform, FT Fourier transform, with this expression where you have an input signal in the time domain. We are going to convert it, to transform that input signal to a spectrum, the corresponding spectrum in the frequency domain with a variable big omega here denoting the frequency. Okay, so that's a continuous time Fourier transform. And it also has a discrete time version that we call discrete time Fourier transform, DTFT. Okay, it looks like this. We'll come to this notation many times. And they are going to be useful. So you can use discrete time Fourier transform to characterize a system as well as to represent the signal. So we'll cover that a lot. But in addition to these two different versions of Fourier transform, we have a few more versions. So there's the discrete FT, and its fast implementation is what is called the FFT. Okay, we'll be doing that too, and as well as the notion of short time Fourier transform to transform a one-dimensional signal into two-dimensional onto the time frequency plane. That can be done. So we will, along the way, we'll encounter different versions of Fourier transform, and they are going to be very useful. So next, I'd like to show you a brief plan for this semester. We are going, first of all, we are going to use, I'm going to suggest this book as the textbook. 课本. Oppenheim, Schaefer, both MIT professors, and this book is now in its third edition. The title of the book is just called Discrete-time Signal Processing. Okay, so check it out. And frankly, I'm not going to teach. This is an introduction course, so we are not going to cover everything in this very pretty thick book. But I highly recommend you to get a copy of the textbook because it's used globally as the most important reference for DSP. Okay, so even if you don't obtain a hard copy, you might be able to, you may want to check out if there's any electronic copy available on the internet or something. So there's a third edition which is not different, which is not that different to the second edition. 第二版 or 第三版, not so different. So I don't mind if you get a second edition somewhere, electronic copy, but this book is highly regarded in the field. So I highly recommend that you get a copy. But otherwise, we are going to selectively focus on only 3 chapters. Chapter 4, Chapter 5, and Chapter 7 of the textbook, while we also touch a bit on Chapter 8 to 10, if time permits. We'll cover like the middle part of the textbook, selectively cover on different topics. So we are not going to, I promise you, we are not going to like cover the entire, every single section of the chapter. That's not what we are going to do. And I will explain the reason in a moment. We are just going to be selectively covering important concepts from the book, while you can keep the book as your own reference. 这样可以吗? So far so good? And also in this semester, as well as last year, we meet every week on Wednesdays and Thursdays, right? So Wednesday will be today, 2 hours, Thursday for 1 hour. So I'm going to format the meetings into Wednesday lectures and Thursday discussions, okay? So on any regular Wednesday when we meet, I give 2 hours of lectures. So starting next week on Thursday, okay? Tomorrow I'm still going to give a lecture because it's just the beginning of the semester. It makes no sense to start discussion, right? So I'll give 3 hours of lecture, including right now for this week. But next week, starting next week on February 27th, we will alternate between 2 kinds of discussion sessions, okay? The first kind is called what I call follow-up discussion, or FUD, okay? Follow-up. So, and the other kind is just discussing the homework, right? 2 kinds of discussions on Thursday. Every other week, we'll alternate between follow-up and homework discussion. And then, even though this course is officially offered in English, and my lectures are all going to be English, I know that we have international students among us, right? So I'm going to almost entirely teach in English, but for the Thursday discussion, I feel that is actually it worked last year. It worked pretty well. So we are going to offer 2 sessions, same content, 2 sessions. And one session is in English, and the other session following the first session will be in Mandarin. Okay, so please feel free to attend either one or both. Yeah, but either one. It's going to be the same discussion, same questions for discussion. But this second session is going to be offered to be conducted in Mandarin, in our native tongue. Okay, so feel free to either attend in 英文 or 中文, English or Mandarin. All right. Any questions so far regarding the format, the course plan? Please choose one to attend, okay? English or Mandarin for Thursdays. Here comes the tentative syllabus, the plan for the entire semester. And you can follow this link. So the PowerPoint has been uploaded to EE class. Okay, so it's available for you to download, but otherwise, this is a tiny URL, NTHU DSP-2025. So I'm going to, this is a Google Sheet, all right? So I'm going to update this Google Sheet constantly. So, but the current plan is that we're going to spend 3 weeks on chapter 4, 3 weeks on chapter 5, and there will be the only one and only midterm over there on the 7th week. And after that, we spend more time on chapter 7, which is the core of this semester. And in chapter 7, it's all about design, okay? Design. IIR, FIR, names for different filters. Impulse, IIR is infinite impulse response, FIR, finite impulse response. So we'll teach you how to design filters, basically. For chapter 7, but before that, we need some kind of background, the foundation knowledge. Okay, before we design filters, we need to know how to analyze a filter. Okay, so chapter 5 is about analysis, to analyze a filter if it's given to you. And then starting chapter 7, we talk about how to design a filter by yourself. Okay, yeah, and there are different kinds and different methods. And then after that, this is quite new, something new I want to try with you. So in May, in the 3rd month of this semester, I'm going to try to offer to you 2 special topics. The first special topic is adaptive systems. And so filters can be made adaptive. So they change their parameters while being used, while they're being used. And that's a very important concept, adaptive systems. And it has something to do, it can be regarded as the prototype. A prototype of what? A prototype of neural networks. We know neural networks can be trained, right? So actually, you can think of neural network as a nonlinear adaptive system. Right? So it's important, like nowadays, to go back to this very topic and talk about and I'm going to share you a few things about adaptive systems, adaptive filters. So there might also be homework related to that. So this is the first special topic. And the second special topic is what I call transform-based information retrieval. Right? Information retrieval. Remember, I just shared with you that signal processing is about having an input and having an output, right? Input is a signal, the output, right? After the chain of actions, the output is also a signal. That's sort of a conventional way, traditional way of thinking about signal processing. But now, more and more, signal processing is sometimes, in certain applications, a signal processing system simply does not produce an output. Or that's probably not fair to say. Sometimes a signal processing system does not produce a signal as the output. But instead, the system can extract information from a signal. For example, I'm now talking, right? A speech recognizer as a signal processing system does it produce a speech output? Mostly not. It produces text output. We call that speech to text conversion, right? So it's about retrieving information from signals. So that's a hot topic. So in the end of the semester, I plan to share with you a few things that I know about speech processing. How do we analyze the content of speech using Fourier transform-based information retrieval? So that's a kind of plan for the last part of this semester before we have a final exam on the very last week of the semester on June the 4th. Right? Any question regarding to this plan? Does it look good? Looking good? Looking good? Looking good? All right, so let's try our best to stick to this plan, right? And now on this slide, I want to share with you a plan on how we are going to give you grades for Thursday's participation, right? So the participation will account for 6% of your final grade, okay? That's the same as last year. So same as last year, you will earn 2% or 2 points for each stage appearance. So the way we're going to discuss, this is a large class, right? So we cannot possibly break you into smaller groups. So instead, we are going to invite you. We're going to have you sign up. I'll explain. So each time when you're going to come up, you are going to sign up and volunteer to come up in front of the blackboard to explain your solution. So that's the plan. Okay. And for each stage appearing on the stage, okay, this is the stage. For each sign up and appearance on the stage, you get 2 extra points. I mean 2%, 2 points for each stage appearance. But I also encourage everybody to ask questions. Okay, question your fellow students. Please don't take it personally. We all need to learn how to accept criticism and offer criticism, right? So in each session, it's not necessarily a criticism, but you will anyway you will earn one point if you ask a question, any kind of question, right? Or make comments or make suggestions on others' solution on the board. Sometimes the same question have different solutions, right? You may, after this one person showed their solution on the blackboard, you might feel that some parts you can disagree, or you can offer a different angle. So that's the chance for you to, if you just raise a question, I will ask you if you have does anybody have a question? And if so, just please raise your hand, and I will invite you to talk. Okay. So for each time you do that, you will earn in each session. If you do that, you will earn 1 point. 1 point per session, not 1 point per question. Okay. Please do not ask 10 questions and expect to get 10 points. Right. 1 point per session. We want everybody to have as much chance as possible. Right. So 2 points for stage appearance, 1 point for offering a question. Okay, so that's the plan. So I calculated that there will be 12 discussion sessions. And if we have 10 people on stage every Thursday, then we have a total of 120 opportunities to earn 2%. Okay, so that's a quick calculation. And last year, about 2/3 of all the students. Last year we had 156 students. 99 of them eventually earned something from Thursday. So that being said, about 57 of them remained silent. Okay, that's okay too, but it's up to you, right? About 2/3 of the students last year scored at least 1 point, and 44 of them scored all 6 points. Okay, so that's just some simply statistics, and we'll see how things work out for this year with you all. Okay, so that's a bit from last year, and that's my plan. And to enable discussion, the TAs will open the link for sign-ups every week. Okay, please do that. Open the link, and then if multiple people, you will share your solution on stage. But if too many people sign up for the same question, that happens a lot sometimes, then we have to make a random selection. So inevitably 无可避免 we will have to make random selection, and the selection will be based on this kind of this principle that we will give higher priority to those who haven't showed up on stage. Okay, please give, yeah. If you are very outgoing and you want to sign up every session, well, chances are sometimes you need to yield. We want to select to give those who haven't showed up on the stage every week, they get the highest priority. Okay, hopefully we enable more and more students to get a chance to stand up here and talk about your solution. Okay, so this is my plan for last year, and this was my plan for last year, and this is also going to be the plan for this year. Okay, any question regarding this arrangement? Any question? Last year, in the end of the semester, I received one complaint. Okay, a student sent me an email complaining about this arrangement, and he told me that this is unfair because he is an introvert. He does not feel comfortable standing up on the stage. So from the beginning, he plans to not sign up and just do his best in the exams, right? So I replied to him that your message is well received, but I feel that nowadays, even if you're an introvert, please try not to be afraid of talking in public, right? We want to kind of foster a friendly environment, okay? So in every question we offer it in friendly ways, okay? So please do not laugh at others, or when you offer a question, when we interact, it's okay to make mistakes. We are all human beings, right? So it's okay to show a wrong answer. You still earn 2 points, okay? If your answer is wrong, which is good. If your answer is wrong, then most likely you do not copy it from the internet, right? You might have come up with your own ideas. So that's great. So please try not to be shy. Please not to be don't be too shy. Okay, so but otherwise that's my reply for the student. I was sorry, but we have specified the rules from the beginning of the semester, right? So there's no way I'm going to reconsider his grade. Okay, so 6 points over here, not too much, but 6 is I think 6 is a good number. Yeah, 6 points is a good number. Right? Any question regarding this plan? So what are the questions from last year? So here I give you a few examples. So we started this way of class meeting in 3 years ago. Okay, 3 years ago we started follow-up discussion, FUD. So this is a sample question, which reads like proof of a theorem, and there's assumption, and there's definition. You prove this equation, and you want to show something, and blah blah blah. So that's kind of the the level of difficulty for the follow-up discussion questions. Okay, another sample question, we asked you to read something from Wikipedia, and then construct an example which converges only at z equals 0. Yeah. Anyway, so these are the kind of questions we are going to offer to you in this semester, right? Follow-up discussion. And then next, I'm going to talk about homework requirement. So we will have 5 homework assignments, and they account to 25% of your score. And the homeworks will mainly be handwritten problems, associated handwritten problems. And one of the purposes is to facilitate your preparation for exams, for midterm, for the final, because both exams are going to be written tests, right? So you need to be prepared. So that's one main purpose of doing your homework, right? Working on your homework. But other than that, on top of that, some of the problems will involve running a MATLAB program and summarizing what you observe, okay? So these homeworks are not going to be really computer homeworks because I don't require you to write your own code. Of course, you can feel free to modify my source code, but I'll offer my source code to you for you to just run it in MATLAB. MATLAB is very super convenient for signal processing, okay? I like it, so I love MATLAB. So love MATLAB. You hear me? I love it. So they're not really computer homework, but they allow you to familiarize with the MATLAB environment, and which is particularly good for signal processing. Okay, so I'll give you some example code, and you'll run it and just summarize what you observe. This is signal processing is like doing an experiment. So we give you the source code, you do the experiment, okay, and tell us what you think. Tell us what you observe, okay? So the homework will consist of mainly the written part, as well as also written part, kind of you need to report on on your observation. And for the handwritten part of the homework, we will always openly discuss all the questions on Thursday, okay? Before each homework is due on Friday. Friday homework due, Thursday we discuss the homework. The Thursday before every homework is due, we will discuss it right here in this classroom. Okay? So the point is that the homework is not supposed to fail you. We want everybody to get nearly full score for every homework. Okay? The homework is not supposed to fail you, and more interestingly, we will not rigorously check on plagiarism. 抄袭啊. We will not check you rigorously. Last year, I simply said we will not check you. Okay. It's not like that we encourage you to plagiarize. No, that's not the concept. But the point is that now, there are so many AI tools, and our homework questions are not going to be so smart that nobody else has ever thought of in the world, right? So highly likely if you post my homework questions on the web or ask ChatGPT or Gemini or DeepSeek, they will give you the answer in 10 seconds, right? Okay, so I figure that now it's meaningless to check plagiarism. So instead, I want to encourage you that homework is your work. It depends on how serious you are, right? If you're serious about something, you try to work it out on your own, right? If you're serious about something. But if you're not so serious about DSP, then yeah, it's up to you, right? This is you're all grown up, right? Yeah, so 都已经成年人了. So we are not going to check you on plagiarism rigorously, but please, if you are serious, try to work out the homework solution on your own, okay? And if there's any difficulty, let me mention that therefore no late homework allowed, okay? Please do not, well, by 15 minutes, that's fine, but late by 2 days, probably not acceptable, right? If you're late by 5 minutes, just miss the deadline, that's fine, send an email to me, I'll just take it, right? But in principle, no late homework allowed. No, we are not going to allow late homework. And the idea is that this sentence, done is better than perfect, right? If you need help, please seek help earlier rather than later. Our TAs are there to help you. Okay, so TAs, I'll ask the TAs to offer TA hours, okay, before the homework. All right? Are we good with this? Can we agree on this? Any question regarding homework requirement, plagiarism? So here's an example of computer exercise from last year. My own field is audio processing. So some of the problems, the computer problems, will ask you to listen to the results of signal processing. And below is one example. So you may read a file, an audio file, and then figure out the waveform and the sampling rate. And then you're going to, last year, they changed the sampling rate and listen to the result. Changing the sampling rate, okay? and using resample, using such kind of function. So that's one example of computer exercise. And now the next thing I need to mention is the grading policy. So the plan is to sum of 4 components. The midterm is, no, not midterm 1, only one midterm. Right? There's going to be only one midterm. So that midterm will be 30%. Final will be 40%. Homework will be 25%. And Thursday participation will be 6%. If you add them up, it's 101 point. Okay. Yeah, so is that clear? Yeah. And so if that's clear, let me also mention that I will remind you that for the final and midterm exams, you are allowed to bring in an A4 size cheat sheet, and you can write on both sides. Okay? Only writing, no printing. Okay, no miniature printing. 不能微缩在影印啊。No 3D, all right? Only 2D, double-sided. No Mobius strip, Mobius, no, nothing funny. Right? A4 size cheat sheet, you can write on both sides, right? And your final letter grade will not necessarily, let me mention this, okay? After we sum up with this proportion, you get a number G, right? Called the summary of your grades. And we do not promise you that your final letter grade, the university uses the letter grade system, right? But we cannot promise you that your letter grade will be direct number to letter conversion. We do not promise you that if you score G of 90 points and above, you will get an A+. We cannot promise you that. Yeah. But we also will not promise you that if you get something below 60, you fail. No, we don't promise either way. Yeah, understand? There will be no direct conversion from your G score to the letter grade. Okay? But instead, what we promise is that we will preserve the ranking. What does that mean? A person with a higher G will not get a lower letter grade. That's our principle. Okay? You get a higher G, then another fellow student, you get an equal or higher grade. Letter grade compared to that person, compared to your friend. Is that clear? Yeah. We preserve the ranking, and our teaching team will reserve the right to determine the grade boundaries. The grade boundary, what's the boundary between A and A+? What's the boundary between B+ and A-? We reserve the right to determine the grade boundaries. Any question? Yeah, so this could be problematic. Perhaps? Are we good with this? We preserve the ranking, and we will determine the grade boundaries. Okay. Yeah. I typically look for a gap. If there is a gap, then I break it over there. So that's almost entirely up to me. Is that okay? Let me just say this in advance. Right? The grade boundaries will be. The right to determine the grade boundaries will be reserved by the teaching team, including myself and the TAs. Right? Typically, I give A+ to 10% of the class. Last year, maybe 12%, but no more than that. Okay. In my personal sort of habit, 我的习惯, yeah, I think A+ should be rare, should be scarce. Okay. We cannot give like 40% of everybody A+. I think that's too much, right? So typically, in the past of my 15 years of teaching career, I usually give A+ to top 10%. All right, so that's the plan. That's my rule. Yeah. Okay, so to summarize, this course, I think it will really interest you if you want to learn Fourier analysis and filter design. Okay? It should also be helpful to you if your work, if you in your future or your current project, you have a project with time domain signals. Okay? If you work on time domain signals, signal that changes in time, then this course should be helpful. And the application could be plenty. So we have applications in communication, multimedia, any virtual reality, augmented reality, biomed, remote sensing, anything, stock market, anything that changes in time, global climate, can be viewed as a signal. And we can process the signal, or we can extract information, right? So applications are plenty, and we teach also a bit about machine learning in the end of the semester when we talk about adaptive filtering as well as information retrieval. And let me also mention that there are quite a few related courses on campus, not necessarily offered in this semester, but please, if you're interested, you may as well consider taking the graduate level DSP directly, especially if you are a fourth-year student, if you happen to be staying for your graduate school. If you already know that, then there's an advantage of taking the graduate level DSP directly, because then you can that can be counted toward your graduate requirement, your graduate school requirement. So please consider that. If you are a fourth-year student, please consider that. And this year, the DSP is going to be offered by Professor Lin Jiawen, who is an IEEE fellow in signal processing. Right? Okay. And another fellow in IEEE, Professor Wang Jinliang, he has been offering adaptive signal processing. So if you get interested, you may consider taking this as an advanced level, a follow-up. Okay, adaptive signal processing, as well as if you're interested in audio acoustics, there's me, as well as Professor Bai Mingshen in the Power Mechanical Engineering Department. Professor Bai Mingshen, who is a fellow of who's also a fellow, and a future fellow. Professor Li Qijun specializes in speech as well as other things. So you may consider taking speech signal processing, another graduate level course. And I think it's also offered this semester, right? So keep in mind, there are different choices: video, image, biomedical imaging, as well as a signal processing IC design, which is the Professor Huang Yuanhao's specialty, right? So quite a lot of courses to take, but this course hopefully will serve you well as an introduction to DSP. Any question, please?